Welcome back to the ninth video in this UEFN or Fortnite optimization chat with GameDevMicah on Twitter, on Discord, and Micah Burneyhausen on LinkedIn. Hit me up. Reply to this video with any questions or concerns you have. This is me just figuring things out as much as I can. So let's try and pull together. Besides for the 30 pages we just went through in those prior documents, what I wanted to do if I kept at this is split them up into smaller documents, honestly. Much like we just did 20-minute videos, I want to, put actual bullet points in the videos of what we're talking about so they're easier to navigate, and also break the document that we just looked at in a smaller 4 to 5 page documents about each section. This was that direction. I had some additional questions, and so I'm going to answer those additional questions through this document. But ultimately, we're going to then, in the next video, video 10, move into the practical example where we just look at the level I've built and how I'm optimizing it. So this will just be a shorter video on just some left open questions. So one was, can we modify the AHLOD or world partition spatial loading range at runtime? I've asked some specialists while I was at Epic Fest if this is possible. They said it wasn't, and I have also not found a way to do it. But maybe there is out there somewhere, but I just haven't been able to. What I did find is that there is a system called HLOD partitions, not just partition, and you can set up multiple different types of partitions that could stream in at different distances, like 3,000, 6,000, 9,000 for that spatial loading range. Now, I'm getting your hopes up here because in Fortnite, even though partitions are exposed in the editor, they will not package. So we can only use one HLOD partition, which will give us only one spatial loading range. To load things out sooner, the best we could do is cull them. So make sure you have culling set up on your actors so that they will de-render as soon as possible. But to unload them, they'll only have that spatial loading range to actually stream out. I mean, I was able to get it working in editor with multiple partitions, but it did not work in package. It would crash out with this error. Assertion failed, B cell names exist. My guess is that this is literally them saying if there's more than one cell name, you can't use multiple partitions and not the package, because that's what happened. So sorry, I did try them out. I tried, and it doesn't work. I also tried net cull distances to see if they had any effect, and I did not see net cull distances have any effect either. So I think you can only use one partition, which will help you spatially unload and get rid of actors. And you can only use, in the net cull distances, I see just didn't really have an effect. I was also asked to create a section on texture packing in the documentation. Texture packing is a pretty industry standard thing that there's a lot of documentation out about. If you want me to help you pack, let me know. I'll briefly cover what you do here. And this is kind of probably small. So, texture packing is taking multiple channels in a single texture and use them for different things rather than just color. Hold on one second here. So if you have, say, the need of a non-transparent material, then when you have a red, green, blue, and alpha channel for your albedo or your material texture, you can use the RGB to render the texture, but then you could pack something else into the alpha. So like maybe you could pack into your alpha a single channel like roughness. And so your roughness could be driven by the alpha channel that you would pack in there. How would you pack it? You would go into a texture or material builder like Photoshop or Kira or what have you. You would tell it that your alpha channel is a different texture or bitmap, and that bitmap would be your roughness. And that way you would get RGB for your material and then your alpha, rather than telling you if it was what transparency the material was. If you don't use transparency and don't have that data, you can pack some other data in there. And why that is useful is that you have to pack red, blue, green, and alpha into a texture. And so you're always paying the cost on disk for whatever the resolution is for those 4 channels. If you're only using 3 of the channels, you could put more data into the 4th channel for the same cost. Likewise, you could take a RGBA texture, and if you have 4 different black and white values that you're driving, you could pack them into each of those 4 channels and then pin them out in the material graph, and then you would have 4 textures represented with 1 texture, and that's called texture packing. And that's really using all the channels that you're forced to store in memory rather than leaving some blank because you're not using them. So that's how you do texture packing, and hopefully you can see how that saves multiples in storage space and overall reduces complexity when you're forced to already have that much assessed. When textures are reduced down in resolution, they also can be packed into a single texture that's larger. So, we talked a little bit in prior videos about if you have a 2K texture and you reduce it down to 1K, you can fit 4 times as many textures in that same 2K footprint. It's a pretty linear or an exponential graph in how much more data larger values take. And so by using smaller values, you can get more in that same space. Then another question was like, what type of workflows are there? Things you can do in Fortnite, or rather in things you can do in Unreal Engine that you then can transfer over into Fortnite. So one of those things you can do is base actors, like the actor class, static mesh component. Those are things that exist in both UEFN and UE5. And so you could build a 5.5 or older actor with a static mesh on it or an ISM on it and set those configurations and stuff in UE5. Use tools like Blueprint to place meshes and create actors, but not the code actually in the blueprint you migrate, but rather use those tools or generation for meshes and placement of meshes, placement of ISM locations that Unreal exposes to you. Then once you've created the blueprint with just those components of a ISM or a blueprint in it, or a static mesh in it, and where it is in the blueprint, you can migrate the blueprint over. So really you can use most anything to create your content in UE5, package that content up into a blueprint, actor without any code in it, just components that you know exist in UEFN, and then you can migrate it over in your UEFN levels. And that way, basically, you get templates that you can build in UE5 using UE5 plugins, tools, and scripting, and then the results of those plugins you can migrate over into Fortnite rather than trying to place things by hand in Fortnite. But you got to make sure all the supported components and classes are there and supported in UEFN, or else you'll get errors when you move it over. HLOD tiles. So next we're going to go through, in the next video, my example project. This example project I'll most likely also upload to, depending on feedback. Or maybe I'll say, hey, if you want my project, get a hold of me, and I'll send it to you so you can play with it. Something along those lines. I'm trying to get the data out, but also I won't be maintaining the project, so I don't know how much I want to let the project be out by itself. So what's the crazy thing I'm going to do in the project? What I've found is through consulting is that people build their levels a bit like they built their levels in Creative. And really, it's your only way to build the levels. Go into the world, drag out a mesh, snap it around, and build stuff one by one. Now, that is building your levels with static meshes, and those are not that efficient. So if we can convert that into ISMs or instant static meshes, that would be more efficient. The problem is there's no way built into Fortnite to do that except for the HLOD or world partition system. Using the HLOD or world partition system, as we covered in prior videos, we can go ahead and grab the world, grab like meshes using that HLOD method of instancing, and merge those into instant static mesh components based on their tile size. And that is what I do. That removes the actors or streams out the actors that are in those tiles when those tiles are shown. And that reduces the work that excuse me, that the system has to do to render or consolidate or do physics or calculate collisions on those actors. And that's why HLODs or ISMs are used at the distance or merged meshes, is to make it simpler out there. What I end up doing as a cool optimization example is I do very large tiles, if not a tile for the entire, one tile for the entire world. That way I capture all the meshes into a single ISM, and then I have client-side collisions that make sure we're nice and tight on collisions, because HLODs don't have them on the client side. In that way, you build your world with static meshes and static mesh components. They do have to be custom because of our use of ISMs versus merged mesh. But when we do that, we can automatically convert from static meshes to ISM using the HLOD system to do it. And then you don't have to touch ISMs yourself by hand. If you want to modify the static infrastructure of your world, you can go ahead and do that and then rebuild the HLODs. And what we end up doing is just never using the actual meshes to do anything besides construct the HLODs, which makes the ISMs. And that's what we're going to walk into. See, about 11 minutes, I've talked about it. Let's see. Document project file. Verify if Niagara data channels are exposed in UEFN. They are not. Fortnite uses Niagara data channels, but they're not exposed down to UEFN yet. That would be the way for us to unify our Niagara systems and not have to generate new systems when we need effects, but just add locations where those effects need to spawn. I expect that Niagara data channels, which is an experimental feature in Unreal, will eventually be baked in and the only thing you can use in Fortnite. We're just not there yet. You can expose material parameters, which is a new thing, via verse. And what you can do with material parameters is you can change the occupancy or transparency of things. So that kind of helps you. I mean, there's a whole bunch of stuff you can do with material parameters. So to help reduce down the impacts of materials at runtime. So play around with material parameters. It's very strong. One thing you can do is perhaps pull custom data and change texture colors and keep all those textures in the same draw call. So there's some crazy stuff. We talked about building blueprints / ISMs in UE5 and migrating them to UEFN. Stats for proof of different optimizations. I've done that. We'll cover that in the level next. And material packing, we covered that a bit as well. All right. 13 minutes. Let's see. Or partition. All right. Yeah. I'm going to pause here and make number 10 the practical example, the real world demo. So hit that play button again, and let's go ahead and look at the actual island I built and how I built it in detail, because that's probably going to be a longer one. Thanks for stopping in. Ciao.